All right. So, welcome to the Spring 2023 Final Exam Review. In these series of videos, I'm going to cover how to do each and every single one of the examples that we have here for the final review. And yeah, that's pretty much that. So, just to kick it off, we're going to do section one, which is solving quadratic equations using square roots. So, the first thing that we want to recall is that anytime we have something of the form x squared is equal to a, then we can cancel out that square by taking the square root of both sides, and we get, let's see, take square root of both sides, and we get x is equal to plus or minus the square root of a. So to solve all of these problems, that's going to be really crucial. The other piece of information is that when we take the square root of a negative number, so such as like the square root of negative a, we get the square root of a times I. So with these two pieces of information, that's how we're going to be able to solve problems 1 through 12. So to do number 1, we have x squared is equal to 16. So since x squared is already by itself, or whatever variable we're going to use, we take the square root of both sides, and we get x is equal to plus or minus the square root of 16, which is equal to plus or minus 4. Now remember that plus or minus means that we have two solutions to this. X equals plus or minus 4 is the same thing as x is equal to negative 4 or x is equal to positive 4. So just remember, anytime you have a plus or minus in your solution, you have two separate answers here. So for number 2, let's see what we have. We have m squared is equal to 73. So similar thing here. We take the square root of both sides, and we have m is equal to plus or minus the square root of 73. From here, we like to check if the square root of 73 simplifies. So we can make a factor tree with this, and unfortunately, it doesn't simplify any further than this. So we're kind of just stuck with that, and that's okay. So we just have m is equal to plus or minus the square root of 73. And now, this is where we're going to use this property over here with our square root of a negative number for number 3. So for number 3, we have x squared is equal to negative 24. So we have a variable isolated, so we just need to get rid of that square. So we take the square root of both sides, and we have x is equal to plus or minus the square root of negative 24. And now this is where we have to introduce our I. So this is equal to plus or minus the square root of 24 times I. But we also want to check if we can simplify the square root of 24. And fortunately we can. So if we look at the square root of 24 and we make a factor tree with this, dividing by the biggest perfect square we can think of. Remember, perfect squares are things like this, where we have, say, the square root of 4 is equal to 2, the square root of 9 is equal to 3, the square root of 16 is equal to 4, and so on and so forth. We can break up the square root of 24 into the square root of 4 times the square root of 6. And the square root of 4 is 2. Therefore, we can say that the square root of 24 is 2 square root of 6. And I shot myself in the foot there by putting that right there. So I'm just going to say that x is equal to plus or minus 2 square root of 6 times I. For our next example, we have number 4. Number 4, we have n squared is equal to 52. And we take the square root of both sides. We have n is equal to plus or minus the square root of 52. And we check if we can break that down any further. So square root of 52, we divide by the biggest perfect square we can think of. That number happens to be 4 and the square root of 13. So square root of 52 is the same thing as square root of 4 times the square root of 13. Square root of 4 is 2, so this is equal to 2 square root of 13. And we have that n is equal to plus or minus 2 square root of 13. We box my answer there. And even on the one over here, we have x is equal to plus or minus 2 square root of 6i. So for number 5, we have k squared plus 7 is equal to 43. So this got a little bit harder, but not by much. All we have to do is subtract 7 from both sides here. When we do that, we have k squared is equal to 43 minus 7. So we have 36. And now we have that k is equal to plus or minus the square root of 36, which is plus or minus 6 because 36 is a perfect square. Next one we have is number 6, which is 36x squared is equal to 49. So this one's a little bit different. With this one, we want to get x squared by itself. So we're still going to divide by 36. So we have x squared is equal to 49 divided by 36. And now we want to take our square root of both sides, and we're going to have x is equal to plus or minus the square root of 49 over 36. So we don't like to have fractions in our square root. And another thing to note is that both 49 and 36 are perfect squares. And so we have this property that if we have the square root of a fraction, like a over b, that it's equal to the square root of a over the square root of b. So really, we can write this as plus or minus the square root of 49 over the square root of 36. And as mentioned before, 49 and 36 are perfect squares, so this is going to be equal to plus or minus 7 over 6. And so x is equal to plus or minus 7 over 6, and this is our final answer. So that was problems 1 through 6. Let's look at the next set. So for the next set, we have, for number 7, that m squared plus 5 is equal to negative 14. We want to get m squared by itself, and so we can move that plus 5 over by subtracting 5 from both sides of our equation. We have m squared is equal to negative 19. We take the square root of both sides, so we have m is equal to plus or minus the square root of negative 19. And because we have the square root of a negative number, we take an we have plus or minus square root of 19 times I. And because 19 is a prime number, we can't break that up any more than that, and so this is already simplified. We can't do anything more with it. For number 8, we have 5x squared is equal to negative 140. So we want to get x squared by itself. We divide by 5 on both sides. We get x squared is equal to negative 28. I had to think hard about that one. And so we have x squared isolated, so let's take the square root of both sides. We get x is equal to plus or minus the square root of negative 28. So we have plus or minus the square root of 28 times I. And then we try to simplify the square root of 28. Fortunately, that one does simplify. So we have 28 can be broken up into 4 times 7. Square root of 4 is 2. So we have 2 square root of 7, which means that we can replace this over here as plus or minus 2 square root of 7 times I. And so that is our final answer for number 8. Do we have enough room for 9? Nah, move up here. For number 9, we have 2 plus 16k squared is equal to 3. We want to move that 2 over to the other side. So now we're going to have 16k squared is equal to 1. Divide by 16 on both sides. We get k squared is equal to 1 over 16. And then we take the square root of both sides. We have k is equal to plus or minus the square root of 1 over 16. So we again want to use that property where we have the square root of a fraction is equal to the square root. So we have the square root of a over b is equal to the square root of a over the square root of b. And this one works out nicely. This just simplifies to the square root of 1 over the square root of 16. Again, ran out of room there. But we have that k is equal to plus or minus 1 over 4. For number 10, we have 2a squared minus 9 is equal to 17. So we want to get a squared by itself. The first thing we should do is do any addition or subtraction. So in here, we want to add 9 to both sides. We have 2a squared is equal to 26. Divide by 2 on both sides. And we have a squared is equal to 13. Take the square root of both sides. We have a is equal to plus or minus the square root of 13. And since 13 is a prime number, we can't simplify that any further. And so we have our final answer. For number 11, we have 2v squared plus 4 is equal to negative 38. Knock out addition or subtraction first, so we subtract 4 from both sides. We have 2v squared is equal to negative 42. Divide by 2 on both sides, and we have v squared is equal to negative 21. Take the square root of both sides. We have v is equal to plus or minus square root of negative 21, which is plus or minus the square root of 21 times I. Now, 21 cannot be divided by a perfect square. Its only factors are 1 and 21, but we don't like to do that. So really the only factors we want to consider are 3 and 7, but those are both prime numbers, and that's how we know that this doesn't break up any further. For the last one, number 12, we have 4a squared plus 4 is equal to negative 18. So, same process as last time. Subtract 4 from both sides. We have 4a squared is equal to negative 22. And then divide by 4 on both sides. And we have a squared is equal to, that's going to be negative 22 over 4, which is equal to negative 11 over 2. So now we're going to want to take the square root of both sides of this equation. So a is equal to plus or minus square root negative 11 over 2. This is equal to plus or minus square root of 11 over 2 times I. So we get that negative out of the square root. And now we have kind of a funky fraction here. We have the square root of 11 over 2. We don't like to have fractions in our square roots. So what we're going to do is we're going to break it up as plus or minus the square root of 11 over square root of 2 times I. And we're going to do something called rationalizing the denominator. So we're going to get rid of this square root in the denominator. We also don't like to have those. How we do that, I'm going to go up here for a second. So if we have the square root of 11 over the square root of 2, and we multiply by the square root of 2 over the square root of 2, remember that this right here is just equal to 1. So we know we're not changing the value of our fraction because any number divided by itself is equal to 1, even if it's something funky like the square root of 2 over 2. With this, we can just multiply across. Remember, when we're multiplying fractions, if we have a over b times c over d, this is equal to ac over bd. And so we get to just multiply across. And also, another property to recall with square roots is if you have the square root of a times the square root of b, this is just equal to the square root of their product. So we have the square root of a times b. So a lot of information taking in right here. However, square root of 11 times the square root of 2 is equal to the square root of 22. And the square root of 2 times the square root of 2 is the square root of 4. But square root of 4 is just 2. So we have square root of 22 over 2. And remember, we're multiplying all of that by I. So our final answer here is going to be plus or minus the square root of 22 over 2 times I. So a is equal to that. And that is our final answer. So that concludes the first video in the series, which is over section 1 of your final exam review. So I will see you on the next one.